So question number 3 on the chapter 1 problem set, chapter 21 problem set had kind of two parts to it, right? And they were asking what's going to happen to the citric acid cycle, or what's going to happen to this compound up here if we add it to the citric acid cycle. And so this is radioactively labeled acetyl-CoA, and specifically it's labeled at that carbon atom right there. All right, so I'm asking the question, what's going to happen to that radioactive label after a single cycle, and then what's going to happen to it again if it continues on through a second cycle through the citric acid cycle. All right, so if you looked at your textbook very carefully, you can actually see that that label is marked on this diagram of the citric acid cycle here. And this diagram of the citric acid cycle actually tracks it all the way through for us. All right, so when we add on the first acetyl-CoA, right, that label ends up right here. All right, it's important to note that this arm of citrate is different than this arm. We're dealing with the pro-R and pro-S arms of citrate. All right, this is not something I want you to know for the exam, but this is kind of an advanced question that I wanted you guys to investigate on the problem set. All right, so that radioactive label is going to specifically end up on the top arm shown here. All right, now when we end up doing the next chemistry, so making isocitrate, all right, when we make isocitrate, the alcohol moves away from our radioactive label here. So it's moving towards the other side, right? Then that alcohol gets oxidized. Our label is still up here, all right? We lose this carboxylate down here as CO2, all right? So that, wrong. My bad. We lose. This is intermediate. There we go. Sorry, we end up losing this carboxylate as CO2. My bad. All right, and we get alpha ketoglutarate. All right, with our label still up here. All right, now in the next step, we end up losing the bottom carboxylate as CO2, and we end up with succinyl-CoA with our label still at the top here. Well, then we end up, we cleave off the CoA. And what does this do to the molecule? This is the really key step here, is it makes our molecule symmetrical here. All right, where this carboxylate up here is equivalent to that carboxylate down there. And so because of this, our radioactive label is actually half up here and half down here. All right, so then when we continue on, all right, making fumarate, our radioactive label is still half here, half here. Making malate, half here, half here. And then we make oxaloacetate in the end. All right, this is where our book basically stops tracking it. But after one cycle, our radioactive label is entirely on oxaloacetate, with half of it on the top and half of it on the bottom. All right, so that's the answer to the first part. What will the label be after one cycle? It'll be half here, half there, all right, on oxaloacetate. All right, none of it ends up in CO2 after one cycle. All right, now let's continue on through the second cycle. All right, well, what happens to the oxaloacetate? Well, we know that this top arm of citrate comes from acetyl-CoA. That means this bottom part, the bottom part right down here, that is the part that comes from oxaloacetate. So our label is going to start out half on each of these two carboxylates now. Well, if we continue tracking this, right, those two carboxylates in the second cycle, our label is half here, half here. All right, well, in this, in the isocitrate dehydrogenase step, we end up losing this carboxylate right over here as CO2. All right, that's the one that falls off as CO2. All right, in the next step, the bottom carboxylate, the one that I have the box drawn around over here in isocitrate, that one again leaves as CO2. All right, so after the second cycle, all of our radioactive label is gone and it is all on CO2 now. All right, so that is your answer for number 3.